Good afternoon, everyone. Myself, B. Kashinath, working as senior lecturer in ECE, Electronics and Communication Engineering. Presently working at Government Polytechnic, Sangareddy. And the subject which I am going to teach is Electronic Measuring Instruments. And the subject code is 18EC504EMI, and it is comes under the third year, fifth semester, and it is elective subject, so it is written as E elective, and it is the first choice of elective, so it is 18EC504 EMI elective A. And the topics which I am going to discuss is test instruments, and the subtopic is introduction to the logic analyzer. So in the previous class we have discussed about the working of spectrum analyzer. So what is frequency spectrum? So frequency spectrum is nothing but on the x-axis you will be having the frequency, on the y-axis you will be having the amplitude or any electrical properties, that is voltage or current of any sinusoidal signal. So while compared to CRO, you will be having the time varying. On x-axis you will be having the time, and y-axis you will be having the amplitude. Where in case of the frequency spectrum, you will be having the, on the x-axis you will be having the different frequencies, on the y-axis you will be having the amplitude corresponding to that frequencies, and it will not be continuous, it will be vertical spikes on particular frequencies only. So and spectrum analyzer works on two principles, that will be, one is parallel filter bank technique, second one is swept frequency technique. And in the parallel filter bank techniques we are using the series set of parallel as the name indicates, set of filters whose central frequencies overlap with each other, so that it will cover the entire range, and it will be used for your audio frequency ranges and somewhat up to the radio frequency ranges. So for going for radio frequency and microwave frequency, we are using the this one, swept super heterodyne spectrum analyzer. We will be having the swept super heterodyne as well as TRF, but we are going for the swept super heterodyne receiver. In that we will be having the major components of one is your super heterodyne receiver, and second one is the CRO. In that one we are driving the horizontal amplifiers through the sawtooth generator or sweep generator, which will sweep from F minimum to F maximum. So and that frequency is controlled by the voltage tunable oscillator, which will works also as a local oscillator for the super heterodyne mixer. And the input frequency, that is the RF or microwave frequency, is applied to the one of the input of the mixer as input frequency and your voltage tunable oscillator frequencies beats together. So when both the frequencies are beats, then there will be a different frequency, a difference of frequency. That frequency is intermediate frequency, which is generated exactly at 100 kilohertz, which will be amplified by the IF amplifier, and will be detected and amplified further, and it is applied to the vertical deflection amplifiers of the CRO. So on the display you will be having the sorry so on the display you will be having the frequency spectrum, that is on the x-axis you will be having the frequency components, and y-axis amplitude of the that is vertical spikes with respect to the frequency. That we are calling it as frequency spectrum analyzer. So that will be very much useful for applications like measuring the characteristics of any sinusoidal waveform with or without modulations, and you can check or you can visualize the amplitude modulation, phase modulations and frequency modulations, and you can visualize the harmonic distortion analyzers, and you can visualize various spectral components you can visualize by using the spectrum analyzer. Now coming to the logic analyzer concept. So here we are going for the logic analyzer. So this is completely in contrast to your CRO. So how it will be looking like, we will see in this period. So on completion of this period, you will be able to know about the introduction to the logic analyzers. Introduction to the logic analyzers. So it is working of the logic analyzer is based on data domain. So working of logic analyzer is based on the data domain, not on the time or frequency. So it is completely digital. Completely it is in digital mode. So it will be mostly used in your CPU or microprocessor based architecture uh, devices. So it is mostly useful in digital domain, not in analog domain. So and this data domain is characterized by different formats. The different formats, as you can have, the data domain is characterized by either state space concepts. So this you came across the digital electronics finite state machines. So you will be having the different states for the different next state actions, like that. So what is the present state, what is the previous state, so what is the next state. So like that, based on that events, we will be having the melee machine and more machine. So based on the previous and present activity, so what is the condition, so that we are discussing in state space concepts. So one of the data domain is state space concepts, and next data domain we are going for the data formats. So data will be available in different formats. So the data may be available in table format or in map format, either in graph formats. So there will be different formats for data. Based on that data, how we are using this analyzer. So data domain is characterized in, first one is state space concepts, second one is data formats, third one is data flows, how the data is flowing from one point to another point. So either maybe you can go for the different switching networks, that may be packet switching network or circuit switching network or message switching networks. So there will be different flow, or maybe you will be having the algorithmic flow. So different data flow will be there based on the architecture also, that may be von Neumann architecture or Howard architecture. So you will be having different data flows from one state to another state. And fourth one is the equipment architecture. So this is as we have said that equipment architecture is either uh, von Neumann or Harvard architecture, like that. It will be also data domain is characterized by equipment architecture also. So totally logic analyzer is based on the data domain. So the data domain is characterized by the four types. First one is state space concepts, second one is data formats, third one is data flows, and fourth one is equipment architecture. So why we are using this logic analyzer? It is used for troubleshooting the digital system. So as we have seen said already, logic analyzer is not used in uh, this analog systems. So logic analyzer is mostly used in only digital systems for troubleshooting. So it is almost similar to oscilloscope in analogs. That is, in analog nature, oscilloscope is useful in, whereas in digital domain we are using this logic analyzer to analyze the logic conditions, like that. So it will be it is nothing but a communication links that interfaces the buses and data paths, that is data highways. So it will used in communication links. So that communication link is not a single link, so it is a parallel connection of buses, so that will interface your equipment with the external world. So communication links, interface, buses and data highways. So that is the introduction to the logic analyzer. So and comparison of this logic analyzer with the oscilloscopes. So oscilloscopes samples the incoming signal at the regular time intervals, and stores the 8-bit digital values. So oscilloscope, what it will do, it will samples the whatever the incoming signal is coming, it will samples the incoming signal at the regular time intervals. Let's suppose or 1 second or 1 microsecond or 1 millisecond, like that. So it will samples the incoming signal at the regular time intervals and stores that 8-bit digital value, and it will preserves the amplitude information. So oscilloscope, on the y-axis you will be having the amplitude information. So this is also preserved, means it will be stored, that is amplitude information is stored in oscilloscope, and signal is analog in nature. This one is very much important. So as the case of oscilloscope, you are having the continuous variation of the input signal on the time or x-axis. So signal is in analog nature, so you will be having the high vertical and horizontal resolution. So you will be having the vertical and horizontal resolution will be very much high due to signal is analog in nature. Whereas in logic analyzers, so it will monitors the multiple channels simultaneously. As we have already said, it is a communication interface from the whatever the device to the external world. So it will monitor the multiple channels simultaneously. As we have already said, signal is in digital nature. So here the signal is in digital nature, and it will provides the timing relationship information. As similar to the CRO, it will also provides the timing relation information, but not in continuous, it is discrete timing relation information. And both these logic analyzers and oscilloscopes are powerful analysis as well as troubleshooting tools. Both the logic analyzer as well as oscilloscope are powerful analysis and troubleshooting tools. And coming to the logic analyzers, these are again classified into two types. One is logic timing analyzers, second one is logic state analyzers. So logic analyzers are two types. One is logic timing analyzer, second one is logic state analyzers. So coming to the logic timing analyzers, asynchronous measurements. So the measurement is not synchronous, it is asynchronous measurement. So the input output relation is not synchronous, so it is asynchronous measurement. Samples the data according to the clock signal at regular intervals. So LTA samples the data according to the clock signal at regular intervals. As this it is asynchronous measurements, sampling rate is faster than the system rates. So logic timing analyzers or asynchronous measurements, it will samples the data according to the clock signals at regular intervals. As it is asynchronous, sampling rate is faster than the system rates. Logic it will stores the samples into the memories and displays. So timing analyzer stores the samples into memories and displays, and the data may be lost between the clocks. So between the so as it will stores the data in terms of the regular clock frequencies. So during between the um, clock frequencies, that whatever the data that is coming in between the clock frequencies, that data may be lost because it is as synchronous mode. So between the clock pulses, whatever the data that is coming, that may be lost, and you can this will analyzes the glitches and computer hardware. So it will also analyze the LTS analyzes the glitches and computer hardware also. Coming to the logic state analyzers, so this one is synchronous measurements, and the samples stores in memory when both are synchronized. Samples are stored in memory when both are synchronized, that is, so with clock it will be synchronized, and the display is either hexadecimal or binary state display. So in case of LSAs, the display is either hexadecimal or binary state display. So the logic state analyzers compared to logic timing analyzers, it is used for synchronous measurements, that is, samples are stored in memory when both the clocks are synchronized, and the display is either hexadecimal or binary state display. So it will check the execution state of the program, and it will also check the microprocessor based equipment. Logic state analyzers checks the execution state of the program, and it will also use for checking the microprocessor based equipment. And nowadays you will be having the modern logic analyzers that will be coming in mixed, means both the combinations are available in the modern logic analyzers. So logic timing analyzers, logic state analyzers, both are combined into one unit. So modern logic analyzers will consist of LTA and LSA in one unit. As LSA, logic state analyzer mode, displays the data in either binary table or map or graph. So binary mode, LSA mode displays the data in either in binary table mode or map or graph, whereas logic timing analyzers mode displays the data in multi-channel timing diagram. So LTA mode displays the data in multi-channel timing diagram. So modern logic analyzers combines the features of both the logic state analyzers and logic timing analyzers into one unit. So where LSA, that is logic state mode, logic state analyzer mode, displays the data in binary table or map or graph, whereas logic timing analyzers mode displays the data in multi-channel timing diagram. So you will be having the multi-channel, so that multi-channel available data will be in terms of the timing diagram. So in this class we have learned about the what is logic analyzers. So logic analyzer is a digital instrument which is used to measure the communication link that is communication bus interface between the instrument and the external world. So it maybe has data highways, and the difference between the logic analyzers versus oscilloscopes, both are important for troubleshooting. So one work in analog domain, one work in digital domain. So one works with respect to timing, and another works with respect to different data domains. So one works stores the data in microprocessor. Another one stores the data in internal to the preservance of aptitude information. So both are useful in troubleshooting. So one is in analog domain, another one is digital domain. And classification of logic analyzers, logic state analyzers, logic timing analyzers. So as the logic timing analyzers are asynchronous and logic state analyzers are synchronous. uh, as the asynchronous mode, the speed is more and it samples the data at regular clock intervals. But as it is asynchronous, during the clock pulses, whatever the data will be there, that data will be lost. But in case of logic state analyzers, so it samples with respect to symmetric conditions. So data loss will not be occur, and somewhat speed will be limited, but data loss will not be occurred, and it is symmetric in mode. So coming to the modern logic analyzers, you will be having the combination of both of these logic state analyzers, logic timing analyzers combined into one unit. So you can have the display of like this. So as the logic timing analyzers are asynchronous, samples the data according to the clock signals at regular intervals. Sampling rate is faster than system rates. So as it is asynchronous, sampling rate is faster. So it will stores the samples into the memories as well as into displays. So data may be lost between the clocks due to asynchronous nature, but it will analyzes the glitches and computer hardwares, whereas logic state analyzes synchronous measurements. So here the samples and stores in memory when both are synchronized. So it will check the condition of synchronizing between the samples which are there and which are already there in the memory. When both are synchronized, then only measurement will be taken place, and it will be having the display of hexadecimal and binary state displays and it will be used in checking the execution state of the program and for checking the microprocessor based equipment. Check for microprocessor based equipment. So coming to modern logic analyzers, which will combine both the LTA and LSA in one unit. So that is the main advantage of modern logic analyzers. Whereas LSA mode displays the data in either binary table or map or graph, whereas LTA mode displays the data in multi-channel timing diagram. Multi-channel timing diagram. So logic state analyzers, just measured equipment clock signals are used. Logic state analyzers, measured equipment clock signals are used. So modern logic analyzers uses both the logic timing and state analyzers into one unit. And frequency to asked questions are classify logic analyzers, explain their operations, and you can have 1 mark questions like what is logic analyzer and what is the difference between logic analyzers and oscilloscopes. That may be asked for. If it is asked for 1 marks, you can write logic state analyzer is digital mode, oscilloscope is analog mode. If it is asked for 3 marks, then you have to explain in detail about how it will operate, both are operating, and how both are useful for how they are useful for troubleshooting and other related explanation. You have to write for the 3 marks. When it is asked for what is the similarities or what is the differences between the oscilloscope and your logic analyzers. And you can also have the question of state the types of logic analyzers. So you can write either for 1 mark logic state analyzer or logic timing analyzers. And if you are asking for the briefly explain the types of the logic analyzers. Then you have to write the logic, what is logic state analyzer, logic timing analyzers, which is synchronous, which is asynchronous, in which case how it will be used, and how the data is stored, and how, which is used in computer hardware checking or glitches, or which is used in uh, execution of the program. Like that you have to write for 3 marks questions. And last one is what is modern logic analyzers. So you have to write the it is a combination of both the logic state analyzers and logic timing analyzers, how they are displaying the data, and what is the advantage of this modern logic analyzers. So these are the different frequently asked questions in introduction to logic uh, analyzers. So any doubts? Okay. Okay, thank you. Thank you for listening. Myself signing off, Kashinath, senior lecturer working in Government Polytechnic Sangareddy. So this is the introduction to the logic analyzers subtopic in test instruments of 5th chapter of electronic measuring instrument in 3rd year 5th semester subject. Myself Kashinath working at Sangareddy Government Polytechnic as senior lecturer in EC. Signing off. Thank you.